Hi, this is Alex speaking. This is my Folio 2 presentation for the illusion of life. In Folio 2, my goals shifted from exploring techniques, tools, and methods that would directly help me to build my Studio 3 game project to focusing on the development of my AI Commander system. Here it is necessary to introduce what is AI Commander systems. In short, it is to let large language model play the game. Large language model will play a role similar to Skynet in Terminator, playing games with player to improve the playability and replay value of the game. Before the advent of AI technology, it usually required a large number of behavior trees to achieve such an effect, and a large number of behavior trees was usually only available to AAA game companies. In addition, many solo game developers often only have ideas, but they are limited by technology, skill, experiments, and time. These limitations usually result in them not being able to make the game they want. But now is 2025, the year of AI, and everyone is exploring the potential of AI. So I decided to use IOL's week 7 to 11 as my chance to try to develop my AI commander systems. In week 7, I attend the Shanghai AI Plus Gaming Summit with my teammates, where I discovered that the independent game publisher Indie Light VP Tony Xiong was presenting almost the same idea as my AI Commander system. This gave me huge confidence that my AI Commander system concept is not just academic or research, it's what the industry actually needs. I also study important papers like RLGPT and large language models and games, a survey and roadmap. These papers showed me that combining large language models with traditional AI is a real research direction. In week 8, I first built the AI Commander test environment in Unity. Then I built a JSON data processing system to handle various stat information in-game. This system can automatically scan all enemies in the scenes, take their position information, and serialize it into JSON format. When the system is running, the Unity console will display real-time position update record enemy position data once a second, and save it to the specified JSON file. Next, I successfully tested whether DeepSeek API can modify the names of enemies in the game. The result was successful, and I observed the usage of the API on the DeepSeek API web page. The number of API requests was 14 times, and the tokens consumed were 3,214. It cost 0.01 RMB. But when I tried to let DeepSeek control the movement of NPC soldiers, a bug occurred because Unity could not parse the complex JSON returned by DeepSeek. In week 9, I have planned to continue optimizing JSON communication from Unity to DeepSeek. But when I spoke with my friends Zena and Panda, they noticed that I have to early on write in a lot of fast and messy code in order to quickly validate the feasibility of AI Commander. So they suggest I pause and check the code architecture first. Zena suggests I use Rider to visualize my code's dependencies and see potential architecture issues. Following Zena's advice, I used Rider to do a full dependency analysis of my game source code. It's clear to see the intricate dependencies between the various scripts, especially the highly coupled network structure of the scripts in the enemy folder. In addition, I used sticky notes and paper to visualize the system architecture of my AI commander. I thought it was necessary to do so, because as I dug deeper and researched, I realized that this AI commander stuff is interesting, but it's also not as simple as I thought at first. In week 10, after fixing the architecture of the code, I created a grid on Miro to understand how the AI commander thinks. I modeled the two main strategies that LLM might execute: aggressive encirclement or defensive protection of the target. This work will allow me to go on to do good prompt engineering in the next steps. Prompt engineering is simply the process of telling the LLM what information is relevant to the AI commander it is playing, such as what it doesn't have access to, what it needs to know, what it doesn't need to know. Technically, this information will be sent from Unity to DeepSeek in the JSON file format and the prompt frame. And then DeepSeek will send its decision information to Unity in the corresponding prompt frame and JSON format. Week 11 is a major update week. As I mentioned in last week, AI Commander visualized using Miro. I found out that Unity engine doesn't have an orchestrator for receiving prompts from large language model via API, but it does have one for receiving command in JSON format from AI commander played by DeepSeek. So I wrote an orchestrator to receive JSON command from the AI commander that DeepSeek plays. Then I made a prompt template in Unity so that no matter what Unity sent to DeepSeek or DeepSeek sent to Unity, they're all in a uniform format and can understand each other's related information. Next, I designed a night grid map according to Week 10 plan and told DeepSeek in the prompt template that it was an AI commander that could control some soldiers to move within a night grid map and that it was going to protect the area number 3. The principle of DeepSeek controlling NPC soldier in Unity is that my orchestrator will first tell DeepSeek the XYZ position information of those NPC soldiers, and then DeepSeek will send back XYZ position information of the NPC soldiers after it was made a decision. I also created 4 parameters in game's layout that will be used to display this in-game data in real time as it updates in real time. In the end, I did it. DeepSeek is sending back its decision information in JSON format to Unity as the prompt template I gave. And Unity successfully received DeepSeek's decision information, and the NPC soldier in the game successfully moved. In short, I let the large language model to play my game.